Welcome to the Deep Dive. We're the place where we take complex topics, dive into the source material, and really pull out the key insights for you.
And today we're tackling one of history's most fascinating and, frankly, scientifically baffling mysteries. The Shroud of Turin.
Exactly, it's this piece of linen cloth, right? And it has this faint, really enigmatic image of a crucified man on it. It's puzzled scientists, historians, everyone for centuries.
It really has. What makes it so unique? I mean, how could an image like that even form? That's the core question.
It's an incredible puzzle. When you look closely, the properties of the image itself are just, well, extraordinary.
Absolutely. You've got things like its superficiality, the fact the image sits only on the very, very top microfibers of the threads. It doesn't soak in.
Which is already weird for something ancient.
Right. And then there's the three-dimensional information encoded in. It's not just a flat picture. The shading relates to how far the cloth was from the body.
And even subtle things, like distortions that seem to match how a cloth would actually wrap around a human body.
Exactly. It's this unique combination of characteristics that makes it so hard to explain and keeps researchers completely captivated.
So that's really our mission for this deep dive. We're going to rigorously examine the main hypotheses about how this image could have formed.
We've been working through a really detailed academic analysis, and it rates these different theories against a whole list of specific image characteristics.
Think of it like a scientific checklist. Does the theory match the evidence? We're looking at everything from that superficiality we mentioned to the 3D data, even how the image interacts with the blood stains, which are actual blood, by the way.
And the analysis uses a clear rating system, which is super helpful here. A theory is consistent if it can explain a characteristic.
Okay.
Inconsistent if the science says it just can't.
Right.
And questionable if, well, maybe it could, but the probabilities are low, or the theory itself isn't developed enough, maybe lacks experimental backing for a firm answer.
So it's a structured scientific approach. We're trying to cut through the noise and see what holds up under scrutiny.
Precisely. This lets us really unpack the strengths and often the significant weaknesses of each idea.
So get ready. This is going to be an academically rigorous look. We'll be getting into the specific scientific arguments, the experimental evidence, or sometimes the lack of it.
Our goal is to give you a kind of shortcut through all this complex research. You'll get a clear picture of why this single piece of cloth continues to be such a profound scientific challenge.
Let's dive in. We'll start with hypotheses that involve some kind of direct interaction or chemical process between a body and the cloth.
Okay, first up, the contact hypothesis. This one's often linked with Paul Vigneault.
All right, so the basic idea, it sounds pretty simple, doesn't it? The image forms just from direct contact. A dead body touches the cloth. Maybe decomposition fluids or embalming oils help create the imprint.
Yeah, it seems intuitive at first glance, like leaving a handprint.
Exactly.
But when you apply those strict scientific criteria from our source analysis, it runs into some serious problems pretty quickly, actually.
Okay, like what?
Well, let's take characteristic C1. Frontal dorsal, same maximum density. The contact hypothesis is rated inconsistent here.
Why is that?
Think about a body lying on a cloth.
Yeah.
Gravity, the weight of the body itself, any liquids involved.
Yeah.
It wouldn't be distributed evenly, would they?
No, definitely not. More pressure underneath, the liquids would pool.
Right. So you'd expect the dorsal image, the back image, to be significantly denser or different in intensity compared to the front image. But on the shroud, the maximum density is remarkably similar for both.
Oh, okay. So the physical expectation doesn't match the actual observation.
Not at all. That's a fundamental physical inconsistency for a simple contact mechanism.
Okay, that makes sense. Now, what about that superficiality? C2, superficial image. This always comes up as a key feature. How does contact handle that?
It doesn't. It's rated inconsistent here, too, and this is a big one. The shroud image is incredibly superficial. The color is only on the topmost fibrils of the threads. It's a microscopic fact, confirmed by STIRP. Now imagine a wet body sweat, decomposition fluids, oils, whatever. What happens when liquid touches fabric?
It soaks in capillary action.
Exactly. It wicks right in, coloring fibers below the surface. That's just basic physics of liquids and cloth. And you simply do not see that deep penetration anywhere in the shroud's body image.
So it's a direct contradiction.
A direct contradiction. It's not just slightly off. It's fundamentally different from how liquid contact works.
Wow. Okay. And it gets even weirder with C3, superficial image backside of frontal. An image on the other side of the cloth, but still superficial. How could contact possibly do that?
It really can't. It's inconsistent. The only way direct contact could put an image on the backside is if the liquid soaked all the way through, coloring the entire thickness.
But you just said it's superficial on the front.
And superficial on the back, too. There's no color in the middle threads. So you have this image just kissing the surface on both sides of the front half of the cloth. Contact just doesn't work like that.
That is bizarre.
And related to that, C6, no cementation, no capillary flow is also inconsistent. Vignon's original idea involved decomposition liquids, aloes, stuff that would bind fibers together, leave residue.
Like a glue effect, almost.
Kind of, yeah. Or at least microscopic evidence of liquids having flowed between the fibers. But Stirp found nothing. No cementation, no signs of capillary flow related to the image. Again, inconsistent with a liquid contact model.
Okay, this is where it gets really interesting for me. The 3D aspect. B3, three-dimensional. The idea that the image darkness tells you how far the cloth was from the body. How on earth does simple contact do that?
It absolutely fails here. Inconsistent. A natural contact mechanism just can't produce that closer equals darker relationship we see on the shroud. Why not? Because contact tends to be binary, all or nothing. If the cloth touches, you get an imprint. If it doesn't, you don't. There's no real gradient based on how close it almost was.
Right. It's either touching or it's not.
Exactly. But the shroud image has continuous shading, subtle variations in intensity that map the body's contours. It's like a topographical map, not a rubber stamp. Jackson, Jumper, and Erkeling did experiments on this. They found that this binary nature of contact is a fundamental problem. It just doesn't provide the latitude to correlate intensity with a continuum of relief variations.
So the 3D data is a major blow against contact.
Arguably a fatal one, yeah.
And then there's B4, vertical map wrapping distortions, another geometric puzzle.
Inconsistent again. The shroud has these specific distortions, right? They match what you'd expect if you mapped points from a 3D body vertically onto a draped cloth.
Okay.
Simple contact only maps the points that actually touch. The kinds of distortions you get are totally different. You can scientifically tell them apart, and the shroud matches the vertical mapping, not simple contact.
And what about B5? No body side images. We don't see the sides of the face, the sides of the body.
Right, and that's inconsistent for contact theory, too. How do you explain that? Some suggest maybe spice bundles prop the cloth up, but there's no evidence that could work with the needed anatomical precision.
And if the cloth was close enough to pick up blood from the hair, for example?
Exactly. If it was wrapped closely enough for blood transfer, why no image from the sides of the face? It's a real problem for the contact idea.
And finally, B11, bone structure. Any possibility there?
Inconsistent. An external contact method, wet or dry, just can't see inside the body to image bones. Physically impossible.
Okay, so that's a lot of inconsistencies. It seems the contact hypothesis, while it sounds simple, really falls short on the shroud's most unique features. Were there any consistencies?
There were a few, yes, but often on less specific characteristics. It's consistent in principle with B1, reverse negative, and day 2, high resolution, maybe in localized ideal spots.
Okay.
And B6, blood and serum makes sense if a body was used. B8, no image under blood could work if the contact didn't cause flow under the blood. And B9, dead human body is the premise. But even then, things like C5, image fiber chemistry, can body liquids actually cause that specific chemical change in linen? That's questionable. And B10, no putrefaction is also questionable, as decomposition products should be involved but aren't seen in the image.
So contact theory, simple idea, but ultimately fails on the most critical, detailed evidence. Let's move to the next one involving natural processes. F2, the gas diffusion hypothesis from Raymond Rogers.
Right. Rogers proposed that amine gases from a decomposing body reacted with a starch layer, supposedly on the shroud, via a Maillard reaction, like food browning.
And crucially, the body was removed before liquids formed, trying to solve the liquid problems of the contact theory.
Exactly. A clever idea. Trying to explain superficiality with a gas reaction.
Yeah.
But again, it hits major roadblocks.
Such as?
Let's look at C4, no superficial image backside of dorsal. Inconsistent. Rogers proposed these amine gases were heavier than air. So what would happen to heavier than air gases underneath the body lying on a cloth? Gravity would pull them down, right? They'd diffuse through the cloth below the body.
Makes sense. They collect underneath.
And they should color the backside of the cloth on the dorsal image area. But that's not seen on the shroud. There's no image on the backside of the dorsal part.
Huh. Another physical expectation not met. What about the chemistry itself? C5. Image fiber chemistry, no paint. Rogers needed that starch layer for the Maillard reaction.
Inconsistent.
Yeah.
This is a huge problem for Rogers' specific mechanism. First, Heller and Adler, respected researchers, did extensive chemical tests and found no starch on the image fibers. Zero.
Oh, well, that's a problem.
It is. Rogers later reported finding faint traces, but even if some starch was there, the typical products of a Maillard reaction are water-soluble.
And the shroud has water stains from the 1532 fire.
Exactly. Those water stains should have smeared or dissolved a water-soluble Maillard product image, but the image fibers were completely unaffected by the water. Stirp confirmed the image layer is not water-soluble.
So the fundamental chemistry doesn't match.
The proposed chemical reaction just doesn't fit the evidence.
Wow. Okay. What about B2? High resolution. Gas, just diffusing. Sounds like it would be blurry, not sharp.
Inconsistent, and you're right, it's counterintuitive for diffusion. Think about confined spaces, like between the legs or buttocks on the back image.
Yeah.
If heavier than air gases are pooling there, those areas should be saturated, dense, probably blurred. But the shroud image is clearly resolved even in those tight spots, not densely colored.
So again, the opposite of what you'd expect.
Right. There are no experiments showing high-resolution imaging via gas diffusion from a body, especially in those confined areas. The shroud evidence contradicts it.
This seems critical. If gas is just spreading out, how does it create that detailed 3D map? Be three-dimensional is also inconsistent.
Hugely inconsistent. This is probably the killer blow for any simple diffusion model. Remember, the shroud's 3D info comes from cloth body distance. How does a freely diffusing gas know how far away the cloth is at every point and adjust its intensity accordingly?
Doesn't seem like it could.
It appears it can't. Experiments trying to model this, like Jackson, Jumper, and Erkeling's work using mathematical equivalents of diffusion, produced low-resolution, distorted 3D results. They explicitly concluded diffusion fails to generate the high-frequency details needed for faces and rejects the hypothesis based on the 3D evidence.
That sounds pretty definitive.
It's a fundamental failure of the mechanism to explain one of the shroud's most defining features.
And if it fails on 3D, it must fail on B4, wrapping distortions too.
Absolutely. Inconsistent. You need that precise high-resolution mapping to get the subtle wrapping distortions right. Diffusion doesn't provide it.
And B5, no body side images, if gas is flowing around.
Inconsistent. Maybe you could argue spice packs block gas on the front, but for the back image, those heavier-than-air amines would flow outwards and downwards, collecting at the sides and between limbs, creating images there. But we don't see them.
Okay. What about B10, no putrefaction? Rogers assumed the body was removed before liquids formed, but the gases are from decomposition, right?
Inconsistent. Yes, the gases themselves signify decomposition is starting. The main issue here is saturation. Areas where gas emission would be highest: mouth, nose, rectum should show really dense, maybe blurred imaging, but they don't on the shroud. The image is still resolved.
So no evidence of concentrated gas effects. And B11, bone structure.
Inconsistent, same as contact. Gas diffusing from outside the body can't image structures inside it.
So the gas diffusion hypothesis, while trying to solve the liquid problem, crashes on resolution, 3D gas distribution, and chemistry. It is consistent, though, on C1, density, if you accept the body removal timing, C2, superficiality, if you ignore the starch problem, C6, no cementation, B1, negative, B6, blood, B7, off-image blood, B8, no image under blood, and B9, dead body. C3 backside frontal image remains questionable.
Pretty much, yes.
Yeah.
It swaps one set of problems for another, essentially.
Yeah.
Okay, let's make a big shift now. We're leaving natural processes behind and moving into part 2. Artistic and human-created hypotheses. This is where we consider if the shroud was, well, made by a person, starting with F3, the painting hypothesis, most famously argued by Walter Macrone.
The simplest idea, perhaps. An artist just painted it.
Seems straightforward, but how does it stack up against, say, C2, superficial image? Can an artist paint something that superficial?
Inconsistent. And this is a massive hurdle. Getting that uniform, microscopic superficiality color only on the very crown of the threads across the entire image, front and back. It seems technically impossible for an artist using paint.
Why impossible?
Any paint, even thin paint, has pigment and a binder. It would inevitably seep into the cloth via capillary action or leave traces of binder cementing fibers together. Stirp looked exhaustively and found no paint pigments, no binders, no capillary flow associated with the image.
So microscopically, it doesn't look like a painting.
Not like any known painting. Certainly not from the medieval era. If it were a painting, its technique would be unique in art history, completely unexplained.
And that weird C3, superficial image backside of frontal, a painted image on the back, too.
Inconsistent. Why would an artist even think of doing that? And how? creating a superficial image on both sides without the paint soaking through. There's zero historical precedent for such a technique.
It sounds incredibly difficult, if not impossible.
And this leads to the core refutation. C5. Image fiber chemistry, no paint. Inconsistent. Bottom line, scientists have not found paint correlated with the image. Instead, the image is a chemical change in the linen fibers themselves. The cellulose is oxidized or dehydrated, browned. It's not stuff added onto the surface.
So it's part of the cloth, not on the cloth. And C6, no cementation, no capillary flow, follows directly from that.
Exactly. Inconsistent. Any known painting method before 1355 would leave those traces, cementation, capillary flow. Stirpe found none. It directly contradicts the painting idea.
Okay, now, the 3D information. B3, three-dimensional. If you're an artist, how do you paint something that encodes distance information so accurately?
Inconsistent. And this is devastating for any artistic hypothesis. Jackson, Jumper, and Ercolane tested this directly. They got skilled forensic artists, coached them, and asked them to draw something that would replicate the shroud's 3D effect when scanned by a VP8 analyzer.
Yeah.
They couldn't do it. The artists themselves said it was down to limitations in visually judging subtle shading and the difficulty of translating that through hand-eye coordination.
So even modern, skilled artists couldn't fake the 3D accurately.
Right. The idea of a medieval artist with no VP8 analyzer, no concept of 3D encoding, somehow intuitively painting distance information into a negative image, it's just wildly improbable. It demands an artistic skill far beyond anything known.
That's a very strong point. What about B4, wrapping distortions, those subtle geometric shifts?
Inconsistent. The shroud's distortions match a vertical projection from a real body onto draped cloth. How would an artist even know about those subtle effects, let alone reproduce them accurately by hand in a negative image? It stretches credulity.
Okay, the blood stains. B6, blood in serum. Could an artist just use real blood?
Inconsistent. It's tricky. Yes, they could use real blood, but the shroud's blood has forensic details suggesting it came from a tortured corpse, serum rings, etc. If the artist just painted it, it conflicts with the dead body characteristics. If they use the body to get the blood stains, then all the problems with painting the body image itself come back.
It's a catch-22.
Pretty much. And B8, no image under blood, no imaging damage is perhaps even more damning.
Why is that? The blood came first, right?
Yes, analysis shows the blood was on the cloth before the body image formed. So how does an artist paint the body image right up to the edge of the blood stains, including the faint, almost invisible serum rings around them, without painting over them or disturbing them?
Especially without modern lighting.
Exactly. No UV light in the Middle Ages. They'd be painting blind around those serum rings, achieving the precision seen on the shroud consistently across the whole image. It seems impossible for an artist.
Wow. Okay, and B9, dead human body.
Inconsistent.
Right.
If you try to combine an artistic body image with real bloodstains from a dead body, you run into all the problems we just discussed, mainly the no image under blood issue and the sheer difficulty of integrating the two seamlessly.
And B11, bone structure.
Inconsistent. Why would an artist paint bones? No reason, no precedent, no way to know what they look like accurately from the outside?
So the painting hypothesis, despite being Macron's big push, really struggles against the detailed scientific evidence. It is consistent on some points. C1, density. C4, no backside dorsal image. B2, high res, an artist can paint detail. B5, no side images. B10, no putrefaction.
Right, but B1, negative image, and B7, off image blood, are questionable. Why would an artist choose those specific unusual features?
Okay, let's move to a related idea. F4, the dusting hypothesis linked to Craig. Using dust or powder instead of wet paint.
Yeah, transferring particulate matter dust, pigment powder, maybe from a bas-relief, or even a body onto the cloth.
So it's still an artistic method. Does it share the same problems as painting?
Largely, yes. Inconsistent for the same reasons on B3, three-dimensional, B4, wrapping distortions, B6, blood serum, B8, no image under blood, B9, dead body, and B11, bone structure. The artist Isabel Pichek's quote is relevant here, needing craftsmanship we cannot produce even today without modern photo methods.
Right. The skill level required seems astronomical. Does dusting have its own specific problems too?
It does. C2. Superficial image, inconsistent. While Craig and others got okay macroscopic results, experiments showed dust particles inevitably migrate into the weave, deeper than just the surface fibrils. It doesn't match the shroud's precise microscopic superficiality. Any fixing agent used would also penetrate.
So dust goes deeper than the image we see. And C3, superficial image backside of frontal.
Inconsistent. That particle migration would make a truly superficial image on the back highly unlikely. And C5, image fiber chemistry, is inconsistent too. Dust or pigment powder is chemically different from the altered cellulose fibers that form the shroud image. It's adding material, not changing the cloth itself.
So dusting fails on superficiality and chemistry, on top of the shared artistic problems. It is consistent on C1, density, C6, no cementation, it's dry, B2, high res, B5, no sides, B10, no putrefaction. Questionable on C4, backside dorsal, might get accidental image. B1, negative, B7, off image blood.
Correct. Now, F5, the Bas-Relief hypothesis, like Delfino's work, using a heated bas-relief, a shallow sculpture to scorch the image onto the cloth.
This feels a bit closer, maybe. Scorch color is similar to the shroud image. But what about C2, superficial image? Can you scorch something that superficially?
Inconsistent. And this is a huge, huge problem. Yes, you can make a scorch that looks similar superficially macroscopically.
Yeah.
But getting that microscopic perfection, only the top fibrils, uniformly across the whole shroud, extremely difficult. John Jackson's team experimented. Heat travels fast in linen. He calculated heat would discolor through the entire thickness in about 1/1100th to 110th of a second.
Whoa, that's incredibly fast.
It is, so you'd need impossible precision and speed, dabbing this hot relief just right over and over across the whole body, front and back, without ever burning too deep.
Jackson said the problems with scorch methods just go on, don't seem to work.
That sounds technically nightmarish. And C3, superficial image backside of frontal again.
Inconsistent. You'd need a second reverse bas-relief for the back, for a detail no one would see, and you still have the same impossible superficiality problem on both sides.
And B4, wrapping distortions. A rigid relief versus a draped cloth.
Inconsistent. How does a rigid, shallow relief produce the subtle distortions that match a cloth draping over a real 3D body with vertical mapping? You'd likely need two different reliefs, front and back, and it's hard to see how an artist could get their specific, complex distortions right using a contact method like this. Okay, but here's the killer question for scorching. B8. No image under blood, no imaging damage. Blood first, then heat.
Inconsistent. This is a showstopper. The blood was there first. If you press a hot bas-relief onto cloth with dried blood and serum rings on it, what happens to the blood?
It would burn, degrade, vary.
Exactly. Blood is much less heat resistant than linen. It would be charred, altered, obliterated. But the blood on the shroud shows no such heat damage, except from the later 1532 fire. The scorching process itself would destroy the blood evidence it's supposed to coexist with.
So the method contradicts the evidence on the cloth, and that impacts B6, blood, B9, dead body, etc.
Yes. Inconsistent for B6 and B9, because you can't scorch under real blood from a body without destroying it. Inconsistent for B11, bone structure. Questionable for B7, off-image blood.
So despite the color similarities, scorching has massive problems. It is consistent on C4, no backside dorsal, potentially C5. Chemistry, scorches altered cellulose, though fluorescence differs. B6, no cementation, B1, negative B2, high res, B5, no sides, B10, no putrefaction.
Correct. But questionable on C1. Density needs unreal temperature control in B3. Yeah. 3D can create some 3D, but experiments show it's different from the shrouds. Needs a very shallow relief.
Okay, one more artistic attempt. F6, combination human body and bas-relief frottage from Bas-Relief. Using rubbing, maybe with a body and a relief, and an acid slurry.
Yeah, trying to combine methods. Bas-Relief used a linen cloth, put it over a volunteer or bas-relief, rubbed it with an acidic pigment mixture, then aged it.
How did it fare on B3, three-dimensional?
Inconsistent. It produced an image with 3D qualities, yes. But detailed analysis by researchers like Heimberger showed it wasn't the shroud's 3D. Bas-Relief's had flat plateaus and sharp cliffs, unlike the shroud's smooth contours. Heimberger questioned the likelihood of a forger achieving the shroud's specific 3D properties by chance. Also, issues like hands looking embedded, unnatural leg shapes were noted.
So similar 3D concept, but different execution and result. B4, wrapping distortions.
Inconsistent. He apparently just had his model turnover for the back image, which wouldn't give consistent posture or the right draping distortions. The face used a relief, inheriting its limitations.
And the acid slurry. B8, no image under blood.
Inconsistent. Bas-Relief admitted painting the blood on the case after making the image, so that's image under blood by definition, contradicting the shroud. But even if he put blood first, that acid slurry would surely damage or react with the blood and serum. Like heat, acid is destructive. We don't see that damage on the shroud.
So acid damage is the problem here, similar to heat damage for sorching, and that affects B9, dead body, B6, blood, etc.
Yes, inconsistent for B9 and B6 due to expected acid damage.
Hmm.
Also inconsistent, questionable for B7, off-image blood, and B11, bone structure, similar to other artistic methods.
What about the questionable aspects for Garlichelli's method?
Several key ones. C2, superficial image is questionable, needs more third-party microscopic study. Fanti and Heimberger noted etched fibers and concerns about the acid slurry wicking in. C3, backside frontal image is questionable, needs a reverse mold, unlikely concept for a forger, still has superficiality issues. C5, chemistry is questionable. Does the acid pigment mix truly match the shroud's altered cellulose chemically? Etched fibers suggest maybe not. C6, no cementation capillary flow is questionable even after washing. Would microscopic traces of the slurry or its effects remain? Probably.
So lots of question marks there, too. Consistencies are C1, density C4, no backside dorsal B1, negative B2, high res in parts B5, no sides B10, no putrefaction.
Right. Another attempt that ultimately struggles with the shroud's unique details.
Okay, let's shift gears again. Part 3, radiation and electrical hypotheses, moving beyond simple chemistry or artistry into more, well, exotic physics, perhaps. Starting with F7, the Proto-Photograph hypothesis by Nicholas Allen, using a camera obscura and light-sensitive chemicals.
Exactly. Like an early form of photography. Treating the cloth with something like silver nitrate, projecting an image onto it using a lens or pinhole in a dark room, camera obscura, maybe using sunlight.
Intriguing idea. But how does it handle B3 three-dimensional? Photography captures light and shadow, not distance directly, right?
Inconsistent. You've hit the nail on the head. Allen's method creates what's called an albedo image, based on how light or dark surfaces reflect light. It's a reflection map. The shroud image encodes distance. Star P scientist Alan Adler was clear. Allen's image type will fail a VP8 test for 3D comparable to the shroud. It would look flat when analyzed for depth.
So fundamentally the wrong kind of image information, and B4, wrapping distortions.
Inconsistent. A camera obscura projects onto a flat surface. It doesn't involve draping a cloth over a body, so it can't replicate those specific geometric distortions caused by the cloth-body interaction.
Yeah.
And B11, bone structure, inconsistent, like other artistic photographic methods.
Interesting how many aspects are rated questionable for this one way.
Lots of unanswered technical questions. C2, superficial image, questionable. How do you apply a liquid emulsion like silver nitrate to cloth without it soaking in via capillary action?
Yeah.
Cloth isn't like smooth photographic film. Getting shroud-level superficiality seems very difficult.
Right.
C3, backside frontal image questionable. Needs a reverse statue subject. Unlikely concept, plus the same superficiality soaping issue. C5, chemistry questionable. No trace of silver or related photochemicals has ever been found on the shroud image fibers. C6, no cementation capillary flow, questionable. Applying a liquid emulsion should leave some evidence of that process, which isn't seen.
And all the blood-related points are questionable too. B6, B7, B8, B9.
Yes, highly problematic. B6 and B9 blood body are questionable. Would the photochemicals damage the blood serum? These testing hasn't been shown safe. B8, no image under blood, is questionable. Okay, in principle, if blood is first, but the chemical damage risk remains. Plus, imagine the difficulty for an artist. Getting a focused camera obscura image to line up perfectly with pre-existing bloodstains from a draped body, especially since the front and back images on the shroud imply different body heights. You might need different setups, different statues. The coordination seems incredibly complex. B7, off-image blood, shares these coordination problems.
So while it's consistent on C1, C4, B1, B2, there may be two high-res, B5, B10, the proto-photograph idea struggles with the core 3D nature, chemistry, superficiality, and practical execution with blood.
Pretty much sums it up. Let's look at F8, the shadow hypothesis from Rodney Wilson. Sun bleaching an aged cloth using a shadow mask.
Like making a stencil image with the sun. But C2, superficial image, is inconsistent.
Yes. Wilson proposed bleaching from the back to remove color from the core, leaving a superficial image on the front. But achieving the shroud's uniform microscopic superficiality this way, across the whole image, seems incredibly unlikely and uncontrolled. How would the artist guide this? And T3, backside frontal image, is inconsistent. If you're bleaching from the back, you shouldn't get any image on the back, let alone a superficial one.
Okay, what about B8, no image under blood? How does bleaching handle that?
Inconsistent. This is a key failure point. Wilson's method starts with an already colored aged cloth. The image is formed by removing color, bleaching. So the areas under the blood stains would be protected from the sun, remaining colored. This means the original cloth color would be under the blood.
But on the shroud, there's no image under the blood.
Exactly. The shroud shows image formation was inhibited by the blood. Bleaching under protection gives the opposite result.
And like other artistic methods, it fails on 3D, wrapping, bones.
Yes. Inconsistent for B3, 3D B4, wrapping, B11, bones, for the same reasons as painting artistic limitations. Also inconsistent for B6, blood, and B9, body, because of the image under blood problem, and integrating that with real blood forensics.
So sun bleaching doesn't seem to fit either. Consistencies are C1, C4, C5, aged cloth chemistry might match, C6, B1, B2, B5, B10, questionable on B7.
Correct. Which brings us to the really interesting ones. F9, the radiation fall-through hypothesis from John Jackson. This is a different beast altogether.
Okay, radiation. The idea is a flash of radiation from the body itself, absorbed strongly in air as the cloth collapses into the body space.
Precisely. It's a dynamic event involving physics beyond simple contact or chemistry. And the striking thing in the analysis we're using is that this hypothesis is rated consistent with all 17 image characteristics.
All of them, after seeing every other theory struggle so much. That's remarkable. Let's break this down. How does it explain C1, same density?
Consistent. The idea is image intensity depends mainly on how long the cloth spends in the radiation zone near the body. If the collapse starts simultaneously front and back, the initial contact points get the same dose, hence the same maximum density.
Okay. And the crucial C2, superficial image, how does radiation do that?
Consistent. This is quite elegant. Radiation interacts throughout the cloth's thickness, but fibrils right on the surface get a direct hit, while those deeper are partly shielded by fibrils above them. So the surface fibrils accumulate a much higher dose.
Like getting a sunburn mostly on the surface.
Kind of, yeah. Plus, the weave structure itself creates micro-shadowing, further concentrating the effect on the very crowns of the threads, explaining that extreme selectivity.
And this leads to the explanation for C3, superficial backside frontal, and C4, no superficial backside dorsal. These were huge problems before.
Both consistent, and it's a key strength. Imagine the top cloth falling down onto the body. As it passes through the radiation zone around the body, both its top and bottom surfaces get irradiated. Result, superficial image on the front and also on the back side of the front.
Okay, that covers C3. Why not C4?
Because the bottom cloth, the dorsal part, is just lying there. It doesn't fall through the body space from below. Radiation only hits it from one direction from the body above it. So no image forms on the backside of the dorsal section.
Wow, that explanation based on the dynamics fits the observation perfectly. What about C5, chemistry? Can radiation alter linen like that?
Consistent. The hypothesis suggests energetic radiation like UV or soft X-rays. This kind of radiation can directly cause photochemical changes in cellulose, linen. Jackson's work showed that aging linen exposed to shortwave UV can produce a browning effect, chemically similar to the shroud image. And C6, no cementation is consistent radiation is non-contact, leaves no residue.
Okay, physics and chemistry seem covered. Body characteristics. B1, negative.
Consistent. Predicts darker image where cloth is closest. Shortest distance, more time in the zone, which is a negative image. B2, high resolution.
Yeah, wouldn't radiation spread out?
Consistent. Because the radiation is strongly absorbed in air, the effect only really starts right at the surface of the body's emitting region. This gives a sharp one-to-one mapping from body point to cloth point.
And the Mount Everest, B3, three-dimensional. How does fall-through radiation encode distance?
Consistent. This is central. Different parts of the falling cloth reach the body surface at different times, based on their initial distance. The longer a cloth point spends inside the radiation zone during the fall, the bigger the dose it gets. Time inside the zone is inversely proportional to the initial distance.
So dose is inversely proportional to distance. Closer means higher dose, means darker image.
Exactly. It provides a physical mechanism that directly generates the shroud's specific 3D properties, linking intensity to distance.
That's incredibly powerful.
Yeah.
B4, wrapping distortions, and B5, no side images.
Both consistent. The model is based on a real body and draped cloth, so B4 fits naturally. For B5, it predicts the cloth bulges away at the sides and top of the head during collapse. Since the radiation is weak farther away, air absorption, these bulging areas get little dose, hence no side images.
And all the blood points, B6, B7, B8, B9, B10.
All consistent. B6 and B9, blood body, fit the premise. B7, off-image blood, is explained by slight sideways cloth movement during collapse, shifting blood relative to the underlying image point. B8, no image under blood. The blood acts as a physical shield, blocking radiation from the fibers underneath. B10, no putrefaction. It's an instantaneous radiation event, no decomposition involved.
And the truly unique one, B11, bone structure.
Consistent. This hypothesis uniquely predicts it might be possible. If the radiation emission was related to mass density, denser internal structures like bones could contribute to the image signal, convoluted with surface features, the long fingers on the shroud. Maybe they partly image the hand bones receiving a higher dose. It's the only theory that even allows for this possibility naturally.
So, the radiation fall-through hypothesis, however extraordinary the event it implies, aligns perfectly with every single measured characteristic in this analysis.
It stands alone in that regard. It provides a coherent, interconnected physical explanation for the whole suite of baffling features.
Which brings us to the final theory. F10, the corona discharge CD hypothesis from Giulio Fanti. Using a strong electric field, maybe lightning-related, to ionize air above the body, emitting UV photons.
Yes, Fanti's work has shown CD can make images on linen, which is significant progress. But comparing it to the shroud reveals inconsistencies. B3, three-dimensional, is inconsistent.
Why? It's radiation too, isn't it? UV photons.
Yes, but the source is different. It's ionized air above the body, not the body itself acting volumetrically. Jackson's earlier electrostatic experiments, similar physics, got poor 3D results. If the CD is a thin layer, physics suggests it acts like a Lambertian emitter radiating evenly, canceling out distance effects, transferring no distance information. Fanti himself called his 3D results unsatisfactory. It seems to need impossible fine-tuning to match the shroud's 3D.
So the geometry of the source matters. And B4, wrapping distortions.
Inconsistent. If it can't get the 3D mapping right, it likely can't get the wrapping distortions right either. B11, bone structure is also inconsistent. The discharge outside the body can't image inside.
What about the questionable aspects for CD?
C3, backside frontal image, and C4, no backside dorsal, are questionable. Can CD explain the double frontal superficiality consistently? And if so, why not a double dorsal one, especially at the size where there's air? Fanti's experiments didn't test the dorsal side this way. B2, high resolution, is also questionable. While some hand images look good, overall resolution, especially face, is debated. CD physics is complex, unstable, hard to control, raising doubts about achieving the shroud's consistent clarity and global 3D correlation.
So corona discharge shows some promise, especially on C2, superficiality, and C5, chemistry, but struggles with the crucial 3D distortions and resolution control. It is consistent on C1, C2, C5, C6, B1, B5, less air at sides, B6, B7, B8, B9, B10.
Correct. It's an active area of research, but faces significant hurdles compared to the radiation fall-through model in explaining the full picture.
Okay, let's synthesize. We've journeyed through contact, gases, painting, dusting, scorching, frottage, proto-photography, bleaching, corona discharge, and radiation fall-through. It's been quite the tour.
What this rigorous, step-by-step evaluation really highlights is the power of the scientific method when faced with a mystery. By testing each idea against the specific observed data, we can see what works, and more often, what simply doesn't hold up.
And the consistent finding really is just how unique the shroud image is. Hypothesis after hypothesis struggles or fails to replicate its specific combination of features: that extreme superficiality, the negative quality, the precise 3D data, the wrapping distortions, the relationship with the blood.
These aren't separate, isolated quirks. They form an integrated whole that seems to defy conventional explanations, whether natural or artistic, as we currently understand and can test them.
And in this analysis, the radiation fall-through hypothesis clearly stands apart. Its ability to be consistent with all the documented characteristics is remarkable, suggesting a truly extraordinary event might be needed to explain the image.
It doesn't prove it, of course, but it provides the most scientifically coherent framework found so far that accommodates all the known facts within this evaluation system.
It underscores that sometimes the most important scientific findings aren't the easy answers, but the anomalies, the things that don't fit our current models. The shroud, through this kind of detailed analysis, continues to be one of science's great challenges, pushing us to question the limits of known processes.
Absolutely. It forces us to confront the possibility of phenomena beyond our current experimental or theoretical grasp.
So we leave you with this thought. Given these profound scientific challenges in explaining the shroud's image by any known natural or artistic means, what does its very existence and this ongoing scientific quest truly suggest? Does it point to the limits of our current understanding, or perhaps hint at phenomena in the universe we haven't even begun to comprehend? Something to ponder.